Okay, we're back. So this is a little different. This isn't Neat Code 150. Instead, it's A plus Computer Science. So, what is this? This is practice website. It has a lot of problems, like Neat Code, like a lot of other practice websites. However, this website, these problems, you are to write. You usually have to end up writing your own classes and whatnot. So, unlike Neat Code, where you're given a method and you have to return some data type in that method to solve the problem, here you do it all from scratch, bare bones. So, we're gonna do some problems. I've done many problems here. I am currently working on the matrix / 2D section, so I'm not sure if that's what I'm going to do. I might do mazes. I don't know. I'm just trying to learn those, so we'll see. You know what? Let's flip a coin. Let's see. We'll say one for matrix, or heads for matrix, and tails for mazes. So flip a coin. It's tails. We're doing mazes. Okay. So I've done this one. Yeah, it's a lot. So let's see. That took me like 2 days, but I was really new to it all. So big group. Problem. Write a program that will read in a matrix of values and then find the largest group of dollar signs. A group consists of all dollar signs touching up, down, left, and right. Dollar signs are not grouped diagonally. A period will be used to represent blank spaces in the matrix. Top left corner of the matrix is 0, 0. Okay. Oh yeah, so the other thing that makes these different is it's more structured like a competitive programming problem. So you're given a data file and you have to solve based on the data file instead of test cases in the main method. But yeah, so first two numbers in the data file represent the row and column size of the matrix. The following values are the matrix values. Okay. So this would be an example of like a sample input, right? We're given a 10 by 10 matrix as represented here, and print out the count of the largest dollar signs in the largest group. So for this example, it says the output would be the biggest group of dollar signs is 16. So let's see how they did that. So it said the groups of dollar signs are dollar signs that are adjacent to each other, not diagonal. So like this group would be these three and this one. So that's 4. That's not it. Here we have 7 plus 2 plus 3. That gives us 12. Plus another 4. That's 16. So this must be the biggest group. Here we have 3 plus 7 plus 3. That's 13. Here we have 2. It's not it. Here we have 4. Okay, so yeah, pretty straightforward. Apparently, I already have some code for this. That literally just looks like my code from the other one. I must have just been trying to test some stuff. But let's restart from scratch. You can change your theme in here as well. I'm thinking. I'm thinking night. Alright. So let's get started. So with these, like I mentioned before, you have to write everything from scratch as if it were like a new class. So let's do that. Okay, the reason I do these imports is the input-output for the reading the file, and utility for arrays, array lists, etc. So, get our scanner. Ooh, it doesn't have automatic closing parentheses. I don't like that. PR honey1.dat. That's the name of our data file as given here. Okay. So the first thing we're reading in is the row and column size of the matrix. So I'm going to keep referring to this because it's the sample input. So we'll say, oh man, tired. Okay, we'll say int rows equals fr.next int columns. Okay, so that's reading in the data. Next, we are going to read in the matrix. Okay. How are we going to do this? We're going to do this using we should do a char array, shouldn't we? Let's do a char array. So, char array, we'll say matrix, we'll just say mat, equals new char array with a length of rows and a row length of columns. Those are our dimensions. So, in this case, it's 10 by 10, right? Now, we need to actually read everything in, because right now this is just a blank char array. So let's read everything in. And we're going to do that using just the classic nested for loop. We'll say mat at let's do this. I'll explain all this after I'm done typing it up. And also to make sure I don't make any mistakes. Okay, so what is this doing? Well, it's reading in the stuff, obviously, but how? So this outer for loop is looping through the rows, right? And so for each loop, or for each time it loops, it grabs the next line in the data file. So let's go over this, like how it would do it simultaneously, or not simultaneously, but consecutively. So for the first time it iterates, I is 0, I++, so it creates a string variable called line, which is fr.nextLine. So right now it's this, right? Then we have a nested for loop that loops through the rows length, so in this case the columns. And so it's row 0, column 0. So mat at row 0, column 0 equals this line, and then the character at position j, right? So the matrix, imagine we have an empty matrix next to here. The matrix at position 0, 0 is equal to this. And then when that nested for loop iterates again, it'll be equal to this, and then this, and then this, and then this. But then when it gets to the end, that outer for loop goes, this becomes the line, then that nested for loop iterates through this, and then the corresponding positions get updated. So let's test that actually by making a little print, like block of code that prints the mat. So actually we can just copy and paste. Get rid of this. We'll say mat at ij. Okay. Hold up. 0 to bounds for length of 0. What? Length 0. Sometimes scanners are buggy. Okay, there we go. Wait, that's not right either. Oh, yes, okay, sorry. Obviously, this is a test input file. So this isn't actually what the real input file would look like. But based on the input file that we're using, it's this, right? So we have a 15 by 12 matrix. So, yeah. Okay, so let's get rid of this print block, and let's get down into the nitty gritty of how we're going to do this. So let me conjure up some ideas. Well, would you look at that? We're back in the editing software. So I made another mistake. So this is me after finishing the last segment of the video. And essentially, I finished the first two segments of the video. The first one you just watched. The second one, which you're about to see, is me going to paint and doing a full-blown one note whiteboard teacher explanation, at least to the best of my capabilities, on how I was going to do the recursion and whatnot. However, for the entire 15 minutes worth of footage, apparently my mic was not recording the whole time. So, what you're about to see is a sped up version of that with no audio at 30x speed, so you can see just what I was drawing, basically, if that interests you. And after, you'll see the final segment of the video where I do the recursion. The final segment was recorded 2 days later. I recorded the first two parts 2 days ago, and now I'm coming back and doing this last bit. So I'm really bad at this. This is crazy. Anyway, carry on. Okay, we're back on Big Group Mazes Recursion. Easy, except it's 2 days later, I think. I don't even remember. But this is basically where I left off last time. So, well, not for me. It was 2 days ago. For y'all, it was 30 seconds ago. So I made a variable, biggest group, that will hold the biggest group. Okay. So now we are going to make our recursive method. So here's what we're going to do. My plan is, I think I already shared my plan. Yeah, I already shared my plan on the drawing board, which I now know apparently does not have audio, so I'll have to go back and voice over for that. But anywho, iterate over the array, and when I come across a $sign, I will call, if it's not already a visited $sign, I will call the calculate group method to calculate its group, right? And if it's bigger than the current biggest group, then the biggest group becomes that current group size. So, and the reason I'm iterating over it and having visited marks, so like, if I'm iterating over, right, and I get to here, it'll run the biggest, or actually it won't. So I'm iterating over, and I find this $. It'll run the biggest group, or like the group for that $. And so then all these $signs become visited. So as I continue iterating through the group, it doesn't rerun the method on these $signs. But since this one is unvisited, it'll run it for all these. But then once it gets to here, it won't run it because it's already visited. Then it'll keep going. It won't run it here because this has already been a visited group. It keeps going until it gets to here, and then that process goes all the way through. So let's do this. Let's make a Boolean array, or a Boolean 2D array that holds our visited locations, and we'll say equals new Boolean, and it'll be the same size as our mat. Okay, so this reads in mat, and we'll say they'll all start off with false initially. So what we're gonna do is iterate over the array, the 2D array. This is a pretty straightforward process. I do it very often. So we'll say if mat at ij, we'll say equals a $, and visited at ij equals false, then we'll say int row. Actually, we don't even need to do that. We just say calculate group, and all we need to do is pass the array, or hold on. Wait, why did I do this? If there's only one matrix, why did I not just make this global? Like, able to be accessed through multiple methods. Okay. Okay. Yeah, that's okay. I don't know why I didn't do that originally. I hope I don't look stupid. I hope this works, but yeah. Okay, so the calculate group method will need, what will it need? It'll need it won't need the mat and it won't need visited because they're declared outside in the class, okay? And then but it will need I, which correlates to the row, and it will need J, which correlates to the column. Like, so those are the positions. And I believe that's it. No, okay. We actually need, we're gonna need rows, and we're gonna need columns so we can check if we are in bounds, and that'll make sense hopefully soon. Okay, let's get started on this method. Hold on, we need one more statement here. So it will calculate group, and we'll say int group equals calculate group, right? And if current group is greater than biggest group, then biggest group equals current group. Okay, and then at the end we'll print biggest group of dollar signs is biggest group of signs is plus biggest group. Okay, that looks right. Okay, let's make this method, shall we? So public static int calculate group, okay, so we're passing to group, we're passing int row, int call, we're saying int amount of rows, int amount of calls. Okay, so first we need to do our base case. So if row is less than 0, or row is greater than or equal to amount of rows, or call is less than 0, or call is greater than or equal to amount of calls, or mat, that's what I named it, yeah, mat at row at call is not equal to $, or we visited that position. If that's the case, we're just returning 0. Okay. Then, if that's not the case, it's an unvisited $, and we have to make it visited. So visited at row call now becomes true. We're going to create a count equal to 0, and we'll say count plus equals calculate group, with row plus 1 call amount of rows, amount of calls. Okay, we're going to copy this a few times, change this to call plus 1, change this to -1, change this to call -1. So these are all of our directions that we can move, possibly, and then we're just returning count. Okay. I hope this works. It probably won't first try, but okay. There is reference from a static context. Well, at least there's no error. Okay. Okay. Let's do some testing time, I guess. Let's say... Zero, zero. Wait. Is that not it? Biggest group of... Oh, wait. Yeah, that's it. Okay. What am I doing? I'm very smart, by the way. Jeez, I can't even, like... Okay, perfect, nice. That was really easy, actually. So, let's kind of go over this. I didn't explain much, so... I've already explained all of this up to this point. Everything I just did, let's go over. Biggest group variable, okay? This for loop, this is like nested for loop iterates over mat, okay? If our current position equals $, and it's not already visited, okay, then our current group is the recursive method. And then I'll explain what the recursive method does here shortly. And then if the current group is greater than the biggest group equals current group, and then print out the biggest group. Now, the hard part. What is this doing? So, this is our base case. If you don't know what that is, it's just how you can stop recursion from happening infinitely. So these checks make sure our position is not out of bounds of the matrix. This makes sure our position we're checking is $, and this makes sure it's not visited. If these are all good, if even one of them is false, then it's going to return a 0. If they're all good, then we set our current position to visited, right? We have a count that equals 1, because, like, we have a $, so our count has 1. And then count plus equals the method, except it'll call it for a different location. In the 4 cardinal directions, or up, down, left, right, and then it just returns the count. So that was AP Comp Sci PR91 big group.